Hey, on Friday, well, last time we were together, we did the beginning of 8.1. We got through 8 worksheet 1A and 1B, and then on to 2A, and we stopped right here. So the last thing we did was talk about shifting the exponential growth and decay graphs. So next, we're going to look at exponential growth and decay models. The format we discussed on Friday was y equals a times b to the x, which can be transformed into y equals a times b to the x minus h plus k, where those are shifts horizontally and vertically. When a real life in quantity increases by a fixed percent each year, or other period of time, the amount y of the quantity after t years can be modeled by the following equation. This is in the same format as these, essentially. So the A part is going to be your initial amount, just like it was Friday. Beginning amount, whatever you want to say, what you started with. And the 1, you know what, R stands for a rate of increase or decrease. What do you think the 1 stands for? Why would you have to do 1 plus the rate of increase or decrease? Pardon me? To get the whole thing the whole part was a good idea. 1 in a decimal form, what's that stand for? What's it stand for is percentage. I heard it. 100. Okay, so what this part is, that's your 100%. And then this is plus your percent increase when you're talking about increasing values. Okay, does that make more sense? That's why there's 1 in it. Because if you're going to increase something, you want the whole amount plus the increased amount. So that's why the rate is 1 plus R. The T, so A again is the initial amount, R is the percent increase in decimal form, T is the time in years. 1 plus R is called your growth factor. So what is that in this format that we started with on Friday? Which one of the variables in this generalized format? That would be your A or your B. Which one? The 1 plus R. Think about it. It's your B. It's the B value. The growth. That's your growth rate. All right. So it's called the growth factor. That would be the B. We called B the growth factor on Friday. All right. If it decreases by a fixed percent, then it's modeled by 1 minus R. That would be your B value right there. All right, and that'd be a decay factor because the rate would be going down, just like depreciation of a car. Okay, so let's do some problems. A scientist estimates that a specimen begins with 730 bacteria, A, B, or X, or Y. Okay, so it's going to be A times 1. It's growing, so it's going to be 1 plus R to the T. That'll be our format. This is your A. If the specimen grows by 35%, R would be 0.35 then. Every minute, that's your T, time is in minutes, write an equation that represents the bacteria's growth. So labels are going to count when you're doing the word problem. So you need to have them labeled properly, and this would be, our answer is going to be maybe in minutes. So the equation would be A or Y in that format up here. That big A, guys, just standing for amount. It's not standing for the growth of the initial value, okay? We're going to use, that's little a. So that's the amount you have at any given time of bacteria. Sounds yummy. 730 times, parentheses, 1 plus 0.35 to the T. And T is in minutes. You could simplify that to A equals 700, oopsie, a weird looking 3. Okay, so A equals 730, and you might want to add 1 plus 0.35 to 1.35 to the T. All right, it says how many minutes will pass before the bacteria reaches a population of 9,000? Well, that's what you want for big A. So if you put in 9,000 equals 730 times 1.35 to the T, do you know how to solve that equation for T? I want you to think about it for a minute. I bet you guys would realize you need to divide by 730, right? But then what would you do if you have 1.35 to the t? Have you ever been taught how to solve for an exponent variable? You have not, okay? So this equation we're going to learn to solve in this unit, but right now we don't know how to solve it. The only way you could solve this problem right now would be guess and check, and that would not be efficient. Okay, so I'm going to show you another way that we have learned how to do, and that would be where we're not going to put the 9,000 in. We're going to do 2 lines in our graphing calculator. You remember how we found the intersection of 2 graphs? Remember the height problems that most of you did not do your homework on? The height, I'm not kidding. The height problems, yeah, you better practice these, else you won't know what to do. Okay, the height problems, I told you if you wanted to know when the how long it took to reach a certain height, we put the new height in the second line, and we put the equation for that graph of the height of the ball or something dropping the object over time in y1. So we want to find out how many minutes will pass before we get to the population of 9,000. So we're going to grab our graphing calculator because it's going to help us do something right now. And then later in this unit, I'm going to teach you logarithms, which are methods for solving for exponents. So we go to our y equals, my calculator is frozen. I'm going to need to reset it. Okay, try see if it's fixed. Yes, okay. 730 parentheses 1.35 to the x power. And then on line 2, I'll put in my 9,000. Now, clearly 9,000 for a y value is quite large. So we're going to need, zoom 6 isn't going to work. We're going to need to do zoom 0, which is zoom fit. There's the increasing value of, or bacteria is going up, up, up and away, grows. And now the 9,000, that's your horizontal line. So we're going to find the intersection. Yes. Don't know why. I've got to find out the reset on that. You know what you probably should do is reset the calculator. So go to second memory, where the plus sign is, like this. It did not work. Okay, so hit 7 and reset it. And then try again. But you're going to have to put the equations back in again. All right, so anyway, when I hit second trace, intersection choice 5, enter, enter, enter. So about 8.37 seconds, you will get to 9,000. Oh, wait, that's not seconds. What was it? There you go. 8.37 minutes. So you will have to have the correct label. You buy a car for $36,000. Did it work, Haley? Okay. Let's go on to this one for right now. Okay. When you buy a car for $36,000, guess what? Cars depreciate rather quickly. Sorry to say it, but the value Y of the car decreases 14% a year. The exponential decay model would be Y equals 36,000 times, it says decreasing, 1 minus 0.14 to the t. And then we want to estimate the car's value after 3 years. So we would just type on our calculator 36,000 times, now 1 minus 0.14 is 0.86 if you want to put that in, and then to the third. So get out of there and just type 36,000 times 0.86. And you can use parentheses or not, to the third. Okay, so it's $22,898.02. $22,898. Okay. Should be labeled with money. It says graph the model on your calculator and estimate when the car will have a value of $15,000. So now we're going to practice that again, putting in the equation, 36,000 times 0.86 to the x power. Don't put in 3 because that would be an answer. And then on the line 2, 15,000. I'm going to zoom fit, zoom 0. That price is coming down, down, down. And then we'll calculate the intersection. Second trace, 3 enters. This is where my calculator froze in my other class. Has anybody gotten a solution? Is yours freezing on you? I have no idea why this freezes my calculator. I don't get it. But it did. So I am going to reset my emulator so I can do the next question. When I did do this on a calculator that worked for me, I got 5.8 years. Yes? You getting 5.8 years, or I'm not getting much response out of you guys. Yes? Okay. About 5.8 years. All right, the growth of an antique table's value after 1975 can be represented by the equation A equals 325 times 1.03 to the t. What was the value of the table in 1975 looking at the equation? All right, $325. What is the rate of growth? Nope, 1.03 is equal to 1 plus the rate of growth, guys. 0.03 then is the rate of growth, which is as a percentage. All right, 3%. All right, got to take away 1. All right, so now this is your practice 8.1. This is the worksheet back, which is 2B. You are assigned this page and 3 and 4. 3, you might have had questions on if you did the graphs as you were asked to from last Friday. Be working on those. We will be doing a new lesson tomorrow. This stuff won't be due until the quiz, but I'm going to tell you when I'm going to check. But I'm just asking that you get busy, start working on them. I'm giving you work time for the rest of the period. Okay? So I'm going to close this out. You may ask me questions anytime you want now. And if you would like to look at worksheet 3A's book assignment, which I told you to do 3A, I'd be happy to answer questions on those. All right, so I'm going to just close this off, though, for now.